side of the right triangle and to solve problems. Okay, let's do this activity. If you have dot paper, you can follow along with me. You can pause this if you want and just play it again when you're ready with your dot paper. Draw squares of sides of 3, 4, and 5 using your dot paper. Use the 3 squares to form a triangle as shown. So you're asked to draw 3 squares. Okay, one has unit of 3, 1, 2, 3, unit of 4, 1, 2, 3, 4, and the unit of 5, 1, 2, 3, 4, 5. Okay, on the one side. So you have now 3 squares. Okay, a 3 by 3 square, a 4 by 4 square, and a 5 by 5 square. You're asked to form a triangle as shown. Okay, and if we do that, this is how your triangle should look like. I'm gonna put this here on top. I'm gonna put this at the bottom. I'm gonna put this on the side. Okay, so I've formed a triangle using 3 squares: a 3 by 3 square, a 4 by 4 square, and a 5 by 5 square. Okay, classify the triangle that is formed. Obviously, that you know it forms a right angle right over here. So this is a right triangle. Okay, what is the area of each of the 3 squares? You know that this is a 3 by 3 square. Therefore, assuming that you know that the area of a square is equal to s squared. Okay, so your 3 by 3 squared will be 9 square units. This is a 4 by 4 square will be 16 square units. And the 5 by 5 square will be 25 square units. So the areas are 9, 16, and 25 square units. What relationship exists among the 3 areas? Okay, if you notice, if I get 9 and add it to 16, it'll equal 25. Or it's 3 squared plus 4 squared equals 5 squared. Okay, 3 squared right here forms a square plus 4 squared will equal 5 squared. Okay, that is the relationship that exists. Okay, now we have discovered that relationship. Once you have discovered that relationship, it becomes a lot easier to apply it to other squares. Let's say you have a square that has a side of 5 units, 12 units, and 13 units. Okay, if we apply the same principle, okay, and create our own triangle, it will also create what we call a right triangle, just like what we did with our 3 by 3, 4 by 4, and our 5 by 5 square. Okay, it will now have areas of 25 square units, 144 square units, and 169 square units. And just like letter C, it will have the relationship of 25 plus 144 is equal 169, or 5 squared plus 12 squared equals 13 squared. Okay? Now, we know that 3, 4, and 5 unit squares work to form a right triangle. What other possible numbers will have the same result? Okay, we have 3, 4, 5, 5, 12, 5, 12, 13. Sample answers for this one may be as follows. It can also be 7, 24, and 25, 6, 8, and 10. And if you notice, okay, all multiples of 3, 4, and 5, okay, will also work. So a 9 by 9 square by a 9 by 9 square, 16 by 16 square, and a 25 by 25 square will also work. Okay, so those are sample units in sample answers for our activity we just demonstrated. Okay, so you have here again, recap, a 3 by 3 square plus a 4 by 4 square equals a 5 by 5 square. Okay, and the triangle that it forms is a right triangle. let's see where this leads us. Okay, it brings us to what a right triangle is first. Let's first analyze the parts to our right triangle. Okay, the sides of a right triangle are adjacent to the right angle. The sides of a right triangle that are adjacent to the right angle are called legs. Okay, remember last time around when we talk about the word adjacent means next to. Okay, and they're called the legs of your right triangle. The opposite side of the right angle is called the hypotenuse. So the opposite side of the right angle, it's called your hypotenuse. Okay, the relationship between the lengths of the legs of the hypotenuse that you notice in the activity at the beginning of the lesson was proven in the 5th century by a Greek mathematician, Pythagoras, and his followers. This relationship is called the Pythagorean Theorem. It is true for any right triangle. So when you talk about the Pythagorean Theorem, it is true for any right triangle. Okay? Not just any triangle, it has to be any right triangle. Okay? So the Pythagorean theorem states, in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. And as a formula, it's c squared equals a squared plus b squared. Okay? Let's look at example 1 and let's see how the Pythagorean theorem works. A rectangle has sides 6 and 8 inches. How long is the diagonal? A diagonal and two adjacent sides of a rectangle form the right triangle. So this is your diagonal right here. Okay? And you know the definition for a diagonal. A diagonal is a line that connects two non-adjacent points in a polygon. Okay? So this is your diagonal and it becomes your C or your hypotenuse. The longest side of your right triangle is always the hypotenuse. Okay? So the legs of a right triangle are sides of the rectangle, and the hypotenuse of the right triangle is the diagonal of the rectangle. Okay? Now let's look at the Pythagorean theorem. C squared equals a squared plus b squared, and we substitute the values for a and b. Now I have c squared equals 6 squared plus 8 squared. Okay, and from there we simplify further. This becomes c squared equals 36 plus 64. Okay, add 36 plus 64, it'll give you 100. C squared equals 100. And again, to solve for c, you get the radical of both sides. Okay, getting the radical of c squared, getting the radical of 100. Okay, you get, oops, there you go. C equals radical 100. Take the square root of each side. C equals 10. Okay, now the reason why we don't take the negative, okay, square root value of c, the reason why we don't get the negative value of c is because there can never be a negative length. Okay, so c equals 10. The length of our diagonal is 10 inches. So the length of c equals 10 inches using the Pythagorean theorem. Okay, next example. In our next example, the Pythagorean theorem can also be used to find the length of any side of any right triangle if the lengths of the other two sides are known. Okay, so if you know what the hypotenuse is and you know what the length of one leg is, you can find out what the other leg is, the measure of the other leg. How do we do that? Let's first look at the Pythagorean theorem and substitute the values for C and for B. So we have 27 squared, which is our hypotenuse, okay, equals a squared plus 25 squared. This is A. We know what B is, 25 squared. Okay, and then, oops, not there yet, right here. Okay, we simplify 25 squared to become 625. To be able to solve for A, we first subtract 25 to both sides of the equation. Commandment number 8. Okay, and simplify it further. Not there yet, this one. Okay, 729 minus 625 is 604 equals a squared, and get the square root of both sides. A equals radical 104. And if you notice, radical 104 is not a square number, so that becomes an irrational number. And using calculator, punch in 104 and then punch in the button of radical x, you get the value of 10.1980393, okay, or about, to the nearest tenth, 10.2 centimeters. So the length of our leg A is 10.2 centimeters. Okay, that's example number 2. And let's look at example number 3. You can use the Pythagorean theorem to see whether a triangle is right. Okay, so to be able to find out if a triangle is right, we can also use that theorem. The measurements of 3 sides of a triangle are given. Determine whether each triangle is a right triangle. And this is a good hint that the hypotenuse is always the longest side of our right triangle. That means the hypotenuse is always our C. Okay? So the hypotenuse is always our C. Let's look at example A, 3A, 5 feet, 7 feet, and 8 feet. We know that this is now our hypotenuse because that's the longest leg. So that's our C. Okay? And you can interchange A and B. It doesn't matter at this point. Okay? So you can interchange what the legs are. Okay? So in this case, we write down the formula for the Pythagorean theorem. C squared equals A squared plus B squared. Substitute the values. A squared, is it equal to 5 squared plus 7 squared? Okay. Is 64 equal to 25 plus 49? The answer is not equal to, because 25 plus 49 is 74. Therefore, the triangle is not right. Okay, one little note here. In this particular case, the B is always the longest leg. Okay, so 7 feet is your B. But for our own purposes, you can still switch them around, which whatever A and B are. But remember in the future reference that B is the longest leg of the right triangle. Okay, let's look at letter B. 10 centimeters, 24 centimeters, and 26 centimeters. Okay, 26 centimeters is our hypotenuse because that's the longest leg. And let's find out if it is a right triangle or not. C squared equals A squared plus B squared. Is 26 squared equal to 10 squared plus 24 squared? Okay, we simply substitute the values for A and B. Okay, simplify it further. Okay, we know that it equals 676 is equal to 676. Therefore, the measurements of 10 centimeters, 24 centimeters, and 26 centimeters of a triangle make it a right triangle. Okay? The last example. The Pythagorean theorem can be applied to solve problems that occur in real life. Let's consider this example. A Forest Service warehouse facility is used as a supply depot and a fighting center. A security fence is needed to protect the helicopter, some tanker trucks, and other firefighting equipment that must be stored outdoors. Diagram of the region to be fenced is shown at the right. How much fencing must be purchased to surround the region? If you analyze the problem, we know all the lengths except for C. Okay? So to be able to find perimeter, we need to add up all the sides of this particular polygon, or in order to do that, we need to find the value of C. So what do we know? We know that the boundary of the region to be fenced what looks like. You must find the perimeter of the region. That is what's being asked of us. In planning this, to find the perimeter, you must find the unknown length C. You can separate the region into more familiar shapes as shown below. So if you get this particular region right here, and break it up into your more familiar shapes, into two rectangles and a right triangle. Okay? So here, the hypotenuse of the right triangle is a side with length c. Find the measures of the legs of the right triangle and then use the Pythagorean theorem to find the length of the hypotenuse. So to be able to find c, we need to find a and we need to find b. Okay? What do we know? We know for a fact that we first need to find the measure of the legs. Legs B, leg A. Yeah, how do we do that? We know that this is 80, okay, feet right here. That's 80 feet, and this is 50 feet. So this should be 30 feet, or 80 minus 50. Okay, that's how we find the first leg. And in order to find B, in this case right here, okay, we know that this is 100 feet all the way across, and this is 28 feet. So to be able to find this measure, we need to get 100 and subtract, okay, and then subtract 28 right here, okay. So once we get 100 minus 28, we find the value of B, and that's what we have right here. The length of B is 72 feet, and the length of A is 30 feet. Okay, what do we do next? After that, apply the Pythagorean theorem, c squared equals a squared plus b squared, now that we know A and B. Okay, so c squared equals 30 squared plus 72 squared, 900 plus 5,184. Okay, 6,084 is the sum. Solve for c, get the square root of both sides. Use a calculator, punch in 6,084 and the radical sign, radical x button. Okay, the answer would be 78. So the value of c is 78. But we're not done because we're asked to find the perimeter. Now we need to add up all the sides. And when we add up all the sides, this is what we come up with. The perimeter of the fence is 336 feet. Okay, so 336 feet of fencing is needed. Okay, and that is the end of our lesson. And make a summary of what you've learned, how to find the Pythagorean theorem, and write down any questions that you may have for this lesson. Thank you.